Okay, up to this point, we have only dealt with monomials, and now we have a binomial, 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 trinomial. Let's start by factoring. Always a good idea to start by factoring, so let's do that. Before we go any further, we just really need to figure out the best way to represent this. We have a fraction times a fraction. Now, knowing what we just learned, I don't know what this was, but that's what we're doing. Knowing what we just learned, we're going to reduce within fractions. And then we can reduce beyond fractions. You don't have to do it in that order, but that's just the best way I know to explain it at the moment. It might change in the next few minutes. Okay, look for GCFs first. I see a GCF of 9. That makes this 9 times x plus 1. No GCF here, but it does factor into x plus 2 and x plus 10. Okay, can you reduce anything there? Nah, I tried once. It didn't work. All right, let's come over here. X plus 2. Doesn't factor. And this one has a GCF of 3, so 3 and then x plus 1. All right, this one works out pretty neatly. And it works out neatly in that there are some things that cancel. So I'm going to cancel those things. I'm going to cancel those factors. Now, let's have a conversation about what a factor is. Factors are things that are multiplied together. If I read the entire numerator using all the appropriate words, I'd say 9 times the quantity x minus 1 times the quantity x plus 2. So everything in the numerator is multiplied together. You can put parentheses here if you find it necessary to group that. I'm going to erase that in just a moment. The denominator is x plus 2 times x plus 10 times 3, which would technically go in the front, times x plus 1. Okay? Everything is multiplied, so I can cancel out any of those things that are multiplied. What I can't do is cancel, don't do this. Don't even write this. It's so wrong, someone might just beat you up. What I can't do is cancel this x with this x. These x's are part of a larger factor. Okay, x plus 2 is an entire unit, an entire expression that is a factor. So I can't just cancel the individual components. That's like saying 1 plus 1 divided by 1 plus 2. Well, that's 2/3, right? Right? You go canceling that right there. Don't try it. Just don't try it. Okay, it's just awkward. All right, let's undo everything that's been done in green. Tap, 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 tap. There we go. And now we're going to start canceling some things. I'll redo some green. We can cancel this entire factor. We can cancel this entire factor. And there's one more, and it's sneaky. But we can cancel 3. 3 goes into itself 1 time. 3 goes into 9 3 times. Now again, if you want to get technical and put in the things that remained, x plus 1 went into itself 1 time. It divided and became 1 over 1. This became 1 over 1 as well. Feel free to put that or not. That is up to you. So, switching to blue, we're going to just write everything we have in the numerator. 3 times 1 times 1, that's 3. Denominator is 1 times x plus 10 times 1 times 1. Well, that's x plus 10. And nothing else reduces. You can't do it. Can't go any further. All right, and one more thing. I want to say this. If I would have ended up with this, can't reduce that either. Don't say, I'm going to cancel those 3's. Don't you say it, and don't you do it either. Because x plus 3, or in this case, x plus 10 is an entire factor. All right, let's go to the next problem, which is sneakily hiding over here. And we always start by looking at it, seeing if we can factor anything, and we can. There's the other problem dangling around, just waiting to be solved. Solve is the wrong word. Solve is when you find what x is. Simplified is what I should say. Let's use appropriate mathematical language. Okay, numerator, it's a monomial, so let's not mess with factoring it. I mean, you can if you want to get all technical and be like, that's 2 times 2 times 3 times x times x. Nah, we're adults. Let's not. I'm going to leave that one the way it is, okay? This one instead is going to, well, GCF, 6x cubed. And then that's going to give me, let's see, divide 6 from that, I get 3x squared. And then 12 divided by 6 is 2. Okay, so can I reduce anything? Yes, I can. And I'm going to. You're going to like it. 6 goes into itself 1 time. 6 goes into 12 2 times. All right, I can also reduce the x squared with this x cubed. 2 subtracted from 3 gives me 1. Now, what I can't do is reduce this x squared with this one. But all this is multiplied. all this is one quantity multiplied. So don't go breaking into this and canceling individual parts. We are ready now to the final answer. 2 divided by 1x, so x, and then 3x squared plus 2. Oh, let's see. All right, one more problem in this video, lurking in the shadows. And this one is going to require a little bit of factoring. And a little bit of factoring never hurt anybody. Let's bring this one to the right. Factor the numerator is going to give you x plus 2 and x plus 7. Factor that denominator. Oh, okay. A little bit of fun factoring here. I need two numbers that multiply to give me 2. Ah, lucky us, it's prime. That must be 2x times 1x. This is where we start experimenting. Going to write down some thoughts. I need two numbers that multiply to give me 21. I could go with 1 times 21. I could go with 3 times 7. Now to get technical, I could reverse those. I'm going to start with 1 and 21. It's going to be not right. 42 plus 1. 42 plus 1 is not 17. Yeah, good luck with that one. So it's not 1 and 21. It's not going to be 21 and 1 either, because that's 2 plus 21 is 23. I want a 17. So it's not those. We've ruled that out. Okay, 3 times 7. 3, 7. I think we found it. I think we found it. We did find it. Let's write it in blue. And here's how we know. Let's put it. 14 plus 3 is the 17 you were aiming for. And I'm going to switch to green one more time, and we're going to cancel. You see it, don't you? Sure hope so. Those cancel, and they divide into each other one time. Put the 1 if you like. And I'm going to have x plus 2 over 2x plus 3. There you go.